Hello, I'm James Chadwick, a physicist from England. In this lesson, we will explore how I discovered the neutron, a neutral subatomic particle located in the nucleus of the atom.
Welcome to our lesson on the discovery of nucleons. We only have one lesson objective for today, but it's a longer one. That is to understand the further development of the atomic model that included the discovery of protons and neutrons within the nucleus. Today's lesson will enhance our chemical understanding by delving into the discovery of protons and neutrons within the nucleus. These discoveries were crucial because they advanced our knowledge of atomic structure, allowing scientists to refine the periodic table and explain chemical behaviour in greater detail. Let's recap the early nuclear model proposed by Ernest Rutherford in 1911. He suggested that an atom consists of a dense, positively charged nucleus surrounded by electrons. This nucleus was thought to hold most of the atom's mass and all of its positive charge. However, further experiments indicated that this positive charge within the nucleus could be subdivided into smaller particles. In 1917, Rutherford himself discovered these smaller particles and named them protons. Each proton carries a positive charge. This refined the nuclear model, showing that the nucleus is composed of individual particles, each with a positive charge. Additionally, remember that Bohr's findings in 1913 informed the scientific community that electrons orbited the nucleus in energy shells. In conclusion, by 1917, our nuclear model had a nucleus in the middle, which includes small particles of protons, orbited by electrons in their energy shells. Despite Rutherford's and Bohr's findings, scientists noticed something puzzling. The mass of an atomic nucleus couldn't be fully accounted for by just protons. According to the theory at the time, the number of protons dictated an atom's mass. Yet, the actual mass of an atom's nucleus was almost always larger than the mass calculated from just its protons. The solution to this mystery came in 1932, when James Chadwick conducted experiments that showed the presence of another type of particle within the nucleus. Chadwick discovered that the previously unexplained mass was due to particles that didn't carry a charge but did contribute to the nucleus's mass. He called these particles neutrons. Neutrons, like protons, reside in the nucleus. While protons have a positive charge, neutrons are neutral. They have no charge. This means they don't affect the overall charge of the nucleus, but do significantly contribute to its mass. This understanding helped explain why atoms with the same number of protons, the same element, could have different masses, a phenomenon we now understand as arising from the different isotopes of the element. For example, carbon-12 and carbon-8 both have 6 protons, but carbon-12 has 6 neutrons, while carbon-8 has only 2 neutrons. The difference in neutrons between these isotopes explains the difference between a mass of 12 and a mass of 8. This discovery of protons and neutrons refined our understanding of atomic structure and laid the foundation for the modern atomic model. Instead of imagining the nucleus as just a bundle of positive charge, we now understand it as a collection of protons and neutrons. By recognizing the roles of both protons and neutrons within the nucleus, scientists could accurately describe atomic masses and predict the behavior of different elements more reliably, significantly advancing the field of atomic theory. Let's have a look at everything we've covered so far. This table highlights the evolution of atomic models, showcasing significant milestones in our understanding of atomic structure. J.J. Thomson's plum pudding model, 1904, was one of the earliest concepts, depicting the atom as a positively charged sphere with electrons scattered within, like plums in a pudding. However, it failed to explain certain experimental results, leading to Ernest Rutherford's nuclear model, 1911. Rutherford proposed a dense, positively charged nucleus at the center of the atom, with electrons orbiting around it, which explained the deflection of alpha particles in his scattering experiments. Niels Bohr further refined this model in 1913 by introducing discrete energy levels for electrons, helping to explain atomic spectra and the stability of atoms. Finally, in 1932, James Chadwick discovered the neutron, a neutral particle within the nucleus alongside protons. This discovery helped account for the remaining atomic mass and the existence of isotopes, completing the picture of the atom structure as we understand it today. In today's lesson, we began by looking at the nuclear model of the atom, which in 1917 was understood to consist of a central nucleus containing positively charged protons, with electrons orbiting this nucleus in distinct energy shells. This model provided a clearer understanding of the atom structure, highlighting the distribution of mass and charge within it. The main focus of this lesson was on the discovery of protons by Rutherford and the identification of neutrons by James Chadwick. We discussed how protons and neutrons reside in the nucleus, with protons contributing to the positive charge and neutrons adding to the atomic mass without affecting the charge. That's all for today. See you next time.